Hello, people. Hello. How are you guys doing? Oh, wait, the chat is off. I'm sorry. Yes, now you should be able to text. I was wondering why this. Hello, hi. Sorry, that's my. I was wondering कि chat में क्यों नहीं कुछ आ रहा है? I was like, what's wrong? We've been silenced. When? When has this happened? You have full freedom to talk over here, to express. I know. I'm good, Hafsa. We'll give it a few more minutes, like a minute or so for people to join. Hello. I'm taking the first lecture, building stats, and then we have the second lecture after that by no, we'll keep a surprise. And after that, we'll do the announcement thing. We'll tell you about what it is, the advanced series and everything. We'll let you know about it for hours. Take care. Yes. Oh, did you guys fill the this form? Today's the last day for NET. Don't forget to fill the form. Will we be solving MCQs today? No, but today onwards you can solve it on the website directly. Right. Yeah. The announcement part, I don't think we should announce record the announcement part. It's a very informal conversation kind of thing. Like it feels weird to put that up on YouTube. Yeah, I'll share it, the details. We'll try not to. We'll try our best to keep it within it itself, but if things go beyond, we'll let you know. What did we do last time, by the way? In stats? What have we been doing so far? Yes. What have we been doing so far, people? In stats? Covariance, regression, correlation. What's the difference between covariance and correlation? Can you explain the progression again? I don't think we have the time for it today, but I'll do one thing. You can go over the video again, day before yesterday's lecture again, If you don't get anything, you can ask me. Or if you're there for the advanced, we'll go over regression all over again properly anyway. Okay? Because I don't think I can explain regression all over again over here. Okay, let me just join to my other device so that I can see your messages. Advanced series details, end domain. Will we get the recordings of Saturday, Sunday? The Saturday is down, I think now. It's unavailable now. But Sunday is still there. 10th May? 10th. 10th is still there. Oh, Saturday is still there then. Yeah. 10th is not taken down yet. So they are still available on. Yeah. If you go to the playlist, you'll find them. Covariance may two correlated things vary together. Okay. D10 is there. I wouldn't phrase it that way because covariance is it's just the way two things are varying and it turns into correlation when it's standardized. Yes. We can't make sense of covariance strength exactly, which is why it needs to be standardized. We have it till the 15th of May. And then from 15th till 20th, we are going to 15th to 19th actually. We'll be doing MCQs. That's also for free only. MCQs for NET and MPhil. Okay. And from 20th onwards, we start the advanced series. Okay. So the MCQs ones will only be like an hour long. We'll go over a few MCQs every single day. Difficult ones, the ones that we have learned are unclear, and they'll be for both NET and MPhil, which is why I'm trying to keep it such that it's there for both. Will the MCQs be recorded? Yes. Actually, no, they won't be recorded. No. Sorry, they will not be recorded because the MCQs, even when Sam was there, it wasn't recorded. Why? Because these are a part of our database, and if we record it, we don't want it going outside. But we will record it, but we won't put it on YouTube. We'll put it on the platform. Okay. Because we don't want it to be out there, outside of the platform. Have to be careful with these things. Yes. Awesome. Okay, we have a lot to cover today, people. Let me open this. So I can see. Today, by the end of this 40, 50-ish minutes that we have left, I promise you, you will not leave without understanding p-values properly. You will understand p-values very well. You'll understand what t-test is doing, not just like, oh, t-test does this difference and stuff, blah, blah, blah. No. We're going to understand what is really going on. What is the t-value? Why is the t-value coming? Where is the, why is standard error coming here all over again? Right? You remember standard error, boy? And how is p-value supposed to be actually understood? So whenever you think about p-value from now on, it's always going to be a map in your head, which I will show you now in a second. That should form. Okay. Let me share my screen. Sorry. Okay, before I get into this, we'll just quickly go up. We'll go up. We've done all of this day before. We looked at deviance by his girlfriend, right? But before I go into all of that, I just want to do a quick refresher on standard error boy, right? If you remember standard error, his job is what? To tell you that your mean is not stable. So if you remember, the standard error usually is calculated like this, right? Very simply, okay? Very simply, you can think of the standard error like a wiggle room, right? If this is your mean, it can wiggle between this room. It can be here or here. If you remember, that was also the core idea of this. I don't think it's recording. Oh yes, that's right. 1 second, I have to give Sarah the thing. Thank you for reminding me. Yes. Hold on, let me just give her permission. 1 second. Not to worry, anyway, Sanjana is streaming. We'll give her a second to record. Yes. Awesome. Okay. So the standard error can very simply be thought of like a wiggle room, right? It's a wiggle room. It's telling me it can be above here also, it can be above here also. It's like a wiggle room, right? That is what we were talking about when we were talking about the standard error the other day. This might come back to you, right? This is what all we were talking about. Like look at here. This is a very huge standard error, whereas this is a very small standard error. It means 0.23 if it's the standard error. So mean plus 0.23 and minus 0.23. This is a smaller wiggle room, and that's good. It's adding more certainty to you. So a smaller and smaller wiggle room, it just means there's less noise, right? That's a good thing. This is what we've been talking about so far. Okay, so this should be clear because it's very important for what we're going to do today. Then we looked at CI the other day. We looked at covariance, correlation, right? You might remember it just very simply as the adding up of deviance by multiplied by deviance by, right? Okay, BD divided by n or n minus 1, depending on the scenario. Then we looked at correlation. We'll look at this formula again today, but like not, I'll tell you, which is the covariance that we took it, we divided by this. Then we also looked at regression, which is how to predict. We had this formula, right? Y equals to the beta 0 plus beta 1 x1 plus error. We did all of this yesterday, day before yesterday. If you're unclear, go watch it all over again. Okay, awesome. So we'll start today. Okay, now almost any or rather every single statistics is based on this. Every single statistic that you will see, almost every actually, is based on this logic. You are checking the effect, some effect, okay? Maybe the mean comparison or maybe something else, the variance, whatever it is. And you are comparing it with how much error is there. The logic is that the error should be less and the effect should be enough, high enough, right? If my error is how noisy thing is, my effect is what can I hear it? Let's say if I hear, let's say, someone takes my name, okay? Is it loud enough compared to how noisy the room is? If the room is too noisy, I won't be able to hear my name. The effect won't be evident to me. So it won't be that important. It won't be that, what we call statistically significant, but we'll get to p-value, don't worry. If the noise is less enough, then even if someone whispers my name, I will still be able to hear it. So this is the logic of a good amount of statistical tests, right? How good the model is effect versus how bad it is. How well it detects something as compared to, like say, someone taking my name compared to how noisy the room is. This is the backbone, the basic fundamental idea behind most statistical concepts. Don't believe me? Look at this. We've already seen one. The effect divided by the error. And the good part about this is also that it restricts it between -1 and 1. And we keep seeing this. Why are we dividing it instead of subtracting it? Why are we dividing it? Because we don't want to know how much error is there. right? Let's say I want to figure out like there's a room, okay? Someone is taking my name. So the sound made by someone taking my name minus error will only tell me that how much is, compared to the error, how much is this is there. And I don't want that. I don't want that. I want to check that if the room is very, very quiet and if I can hear my name, that's a good thing. So it's loud enough, right? It's loud enough when the room is less noisy. Whereas if the room is slightly more noisy, this name taking should get louder. It needs to get louder for me to hear it. So that is the logic behind it. And the fun part, you see this everywhere. Chalo, who can tell me what formula these are? You get nothing from my end, but yeah, let's see if you can guess them. T value, okay, this is the T test. ANOVA, yes. NOVA, chi-square. And the last one? These won't be scary. By the time we are done with this foundational and the advanced series, none of this will be scary. In fact, this won't be scary today only. No, that's not petty test. This is Cohen's D, effect size. And look at each formula, they're doing the same thing over and over and over again, right? Here I'm doing what with the t-test? I'm comparing the means, right? Here I have x1, which is mean of the first group, and x2, which is mean of the second group, and I'm subtracting them to get the effect. And I'm dividing it by what? This thing is called the standard error of the difference. We'll get over that, don't worry. So effect over error. Same thing over here with our F ratio as well for ANOVA. It's looking at the mean squares between compared to the mean squares within. So this is the effect which tells you that, okay, there is a difference between the groups, whereas compared to how much noise or variance is within the group. So that will be the error. Same thing over here with Cohen's D. Effect, error. Same thing with chi-square. How much it's deviating like from the expected value, and here what is the expected value. You will keep seeing this happen again and again and again and again all over psychology, or all over stats. Right. So let's look at this example. Okay, to understand the one sample t-test, that there are 25 students from a coaching center, okay, who have appeared for the NET exam. And I want to see if the average score, okay, the average score is 203, is significantly different from the cutoff 198. Okay, the 198 cutoff is not, I don't think the cutoff was 198 this time. But I want to see if this score of 203, is it significantly different from 190. So very simply, what will I do? That average of, like, let's say my students and the cutoff. So 203 minus 198, how much? 5, exactly. Now, what does this 5 tell me? Nothing. This 5 means nothing. This 5 could be 3, this 5 could be 10, right? Depending on what this score is, it would mean nothing to me. You want to read this again? People have appeared for the NET exam. Okay, the people in the coaching have appeared, have scored 203, but the exam cutoff, the NET cutoff is 198. So I want to see if my students have scored significantly higher from the cutoff. But I'm seeing here that the difference on average of mine and this is, well, 5, and that makes no sense, right? It's not big enough, not loud enough, or small enough. I don't know. No, standard deviation is not coming here. This is just basic subtraction. Okay, so this 5, it makes no sense to me. It makes no difference. So a difference of 5 exists between our scores and the cutoff. But how do we know that this difference means anything? How do we know it's of any value, right? And that is where this comes again. My effect of my 5 is there. I want to compare it to how much error is there in my data. So I would do something like this. I would take my mean. I would take a hypothetical score. Here I'm assuming the cutoff is 198. No, I would take this hypothetical score and I would compare it to the standard error. This is what we call a one sample t-test. Let's take an example. See, this is my score 198. This is, sorry, 203. The cutoff is 198. Let's say that the standard deviation is 10 and divided by the square root of n, because if you remember, there were 25 people. What do I get? What is the value that I get? Negative 2.5, 2.5, that's not a problem. So how is it negative 2.5? Now, this 2.5 actually means something. And I'll tell you what. This 2.5 now is comparable. It actually is something that I can compare. Right? 2.5. So the t value, if you see here, it's on the spectrum. So if you ever think of a t value, right? This is the t value. This is the t value. Right? T equals to 2.5. So if you ever see a t value, I want you to think like this. So at 0, if my value was 0, it means there's no difference. Right? This is our null hypothesis, that there is no difference. Our null at 0. This is what we write, right? There's no difference over here. What value we got? 2.5. So it's somewhere here. Right? So we are basically checking how far is it from the null. Right? If this null over here, 0, is basically like it's saying that there is no difference, how far is it from the null? The value we received is here, 2.5. No, negative 1. It can, again, it doesn't make a difference even either, as long as it's moving as far as possible from 0 in either direction. Oh, sorry, I think I forgot to add negative 1. No, it should be there. That's a design error. That's fine. Okay. So in that context, you need to understand what the p-value is doing. Okay, the p-value standing for probability. Probability. It's very simply asking one question and one question only. You are taught put p-values as 95% chance, 95% probability, 5% error. Ignore all that crap. You just remember one thing. How likely is it? Okay, that I'd see this difference over here. This difference you can see from 0 and 2.5. This difference, or something more extreme, given that the null is true. Okay, what does that mean? It means that if the null is true, what is the null? 0. If this null is true, okay, like we're assuming that the null is true. Fine. We're assuming this. So if the null is true, is it very likely for me to get a value of 2.5? What do you think? Okay, let's compare. If the null is true, would I get a value of 0? Is that very likely? Yes, that the null is that there is no difference. Let's do a comparison. If my null is true, is it likely I'll get a value of 0? Yes or no? Yes. Okay. If my null is true, is it slightly less likely for me to get a value of 0.5? Yes. If my null is 0, is it slightly less likely now for me to get 1.5? As compared to this, let's say this 0.5. So you're seeing here, as I'm moving more and more, this becomes less and less likely. So if I got a t value of 5, will that have a less probability compared to 2.5? Yes, no, yes. Why? Because the 5 is here, right? Farther and farther, you can see here. So very simply, the idea, if I can draw it better over here, you can see here that if the value is like not that far away, which is why we're taking a 0.05, right? That when we are taking the p-value, we want to see that if my t-value is here at 2.5, is it likely for me to see such a big difference given that the null is 0? So it's getting less and less likely as I move more and more further away, which is why the p-value keeps dropping and dropping, which is why we end up with 0.05. If I got a t-value of, let's say, 104, my p-value would be something like 0.000000001. Why? Because it's very, very, very unlikely for me to see a difference this big, given that the null is true. Does that make sense? Yes, no, maybe. Need me to go over that again? What does it mean for the null to be true? It means that there is no difference, right? Over here, I'm seeing that this effect is there, right? What am I doing? I'm setting up a null and I'm setting up a alternative. What is my null? That there is no difference between 203 and 198. It's not a significant difference. I'll repeat, but let me just clarify null again. P-value is not the likelihood of null hypothesis. No. We are not assuming, we're not looking for the probability of the null, right? So alternate over here is that there is a difference. There is difference. So if I can put it very simply, I am trying to look at the probability of getting my data, my value that I got, let's say a value of 2.5, given, okay, this is the straight line we usually put when we want to say something is like, given that the null is true. If you want me to give a simpler example, let's take this, okay. Hold on, let me come back. Let's say that there's this guy over here, okay. Let's say deviance by 0, okay. And let's say that someone is accusing him of murder. What do we say when someone is, accused of murder? We say innocent till proven guilty. Guilty. This is a null, right? That there is no difference. That is what we say, that you are innocent till proven guilty. This is something that applies for everyone. Innocent till proven guilty, and that is what the null is. That we're not claiming that the null is true, because I can't claim that you truly are innocent, but we're just assuming that for everyone to be the case. We're not saying what is the likelihood you are innocent. No. You are innocent. Till proven guilty, you are innocent. There's no likelihood of you being innocent. You are innocent. Okay. So what if I find a weapon in Deviance Buy's house? So then the question is, what is the likelihood of me seeing a murder weapon? Okay, I'll put over here the probability of seeing weapon given that he is innocent. I would say very low, right? If you're innocent, you should not have a weapon in your house. The murder weapon should not be in your house. So there is no difference until proven that there is a difference. Again, there's no proof really over here. So further you move from 0, the less likely. Yes. What's the t here? The t is the t value. It's a standardized, in a way, a standardized t score that you get. Right over here, we were comparing. I'll come back to that example. But t value is this comparable value we get, because earlier when I got just 5, that did not make sense. But t over here, I can now compare, because 0 indicates that something is like, there's no difference. That's the null, no diff. But if I'm putting it on a standardized t score, I can compare, and this then gives me the p value. Right, coming back to our example over here with this guy, where'd he go? This is what we are doing as well. That what's the probability of me seeing, say, a particular t value, given that my null is, let's say, at 0 is true. So if I get a t value of, let's say, 0, and my null hypothesis is saying that there's no difference, okay, let's say at 0 is 0. So this is very, very high, very likely. Okay, what if I get a data of 1 and my h0 is assuming that it's 0. This is slightly less likely. I'll make a small arrow, choto arrow. Okay, what if I get a probability, the t-score of let's say 45? This is too big a deviation. 0 equal to very, very unlikely. So this is the logic of p-value, that how likely is it, right? That I'm going to see this difference or something more extreme, given that the null is true, not if the null is true, given that the null is true. So you can see here, this is a very small difference, very chotu difference. So here, it's not that likely for it to be very different from the null because it's not that far. But as I keep moving more and more and more, right? The t value, okay, this is the t value. The p value starts getting smaller. So if I get a t value of 6, it gets smaller. If I get a t value of 7, it gets even more smaller. If I get a t value of 8, it gets even more smaller. The p value, okay? The p value is one that's getting smaller. Is this clearer? Yes, as the t value increases, right, the more your p value increases. Why is that happening? Why is this happening? Right? Because what is the t value even telling you? The t value is telling you that what is the difference, right? The degree compared to the error. So let's say that over here with the error, instead of 10, I take 1. Instead of 10, I take 1. What value do you get? Tell me. 5. So which will have a smaller p value, 2.5 or 5? Exactly. 5 will have the smaller p value, right? Because what the t-test is doing is it's taking your effect and error and it's comparing and giving you a comparable value. Then you can put it on that 0, 1, 2, 3, and you can compare. So when my standard error was 10, okay, I was getting a value of here. When it was 1, right? What's up? Yeah. When it was 1, you can see here, I reached 5. Okay, let's say that I have a standard error of 0.1. What do I get now? What value do I get now? Instead of 10, it's 0.1. What is the t value then? If instead of this 10, it's 0.1. Can someone confirm? You can see how it increased so much, dot, 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 50. So as the standard deviation and the standard error, the error is getting smaller and smaller, this strength, this difference is bigger and bigger. It means it's like it's louder and louder, right? The same thing as with the room. If someone takes my name, right, and the room is very noisy, if the room is very, very noisy, my name will be less, audible to me. I will not be able to hear it very clearly. So someone needs to then speak louder. The difference needs to be louder then. But if the room is less noisy, what's going to happen then? Even if they whisper it, I'll be able to hear it. Then I compare it on that thing where more and more it moves away, right, from the null. The less and less likely does it become to see such a difference. Yeah, but yes, the lesser the error, the better. But usually that's not really in our control. It's whatever the data is showing. So how do we interpret this? If I get a p-value over here, let's see, where is it? You can see here, take this, right? If I get this difference, let's say the t-value of 0.5, and I got a p-value of 0.76. We would describe this as not significant. But what does that mean? It just means that it's quite likely for it to be, for me to see such a thing, given that the null is true. It's quite likely for me to see such a difference, given that the null is true. Okay, what if I got a p-value of, let's say, -6? Okay, so here the p-value then would be 0.001, because it's unlikely for me to see such a difference, given that the null is true. Is it clear so far with p-values? Any doubts? Which part is unclear? How all of it, which part comes together? Where do you find the p-values? You calculate them. Usually, if you ever run a t-test on your computer or something, the p-value will be there along with it. If you want me to give you one more easier example, let's say that we're taking the scores of women. Let's say they scored 18 on depression and men scored 18 point. Okay, wait, let's take 18 for men over here. Okay, men scored 18 and women scored 18.1. Okay, men scored 18 point, women scored 18.1. What is the difference? 0.1, right? And on top of that, I would have the standard error. I don't know the difference, but whatever. Okay. So this 0.1 error, this 0.1 difference, I want to see, is this really strong enough? So if the error is very, very small, then this might even like someone whispering, it's like someone whispering, right? So even then it becomes significant. And what does that even mean, it being significant? When I get the t value, right, the critical value, you can also then look at the t value and the critical value. You can look at the tables, then the critical value tables, or you can just run the formula, that's fine, to get the p value. So if I get a p value of, let's say, 3, it will show me that I have a p value of, let's say, maybe 0.01 or 0.05, which means that it's very unlikely for me to see this difference, this difference, given that the null is true. Why are we comparing our value with the null? We're always assuming, because with the same case with the innocent person, right? You are always assuming that they are innocent, right? Innocent till proven guilty. That is exactly how it is with the null. You will always start assuming that there is no difference. So how likely is it for me to see this data that I'm seeing, given that there is no difference in reality? So if this is strong, then I can consider it as good support for my hypothesis. It doesn't prove anything. It proves nothing. It doesn't count as proof, but it gives me good support, right? Good support for my claim. Because even if we are assuming that there is no difference, no, wait, that should be equal. Even if we're assuming that there is no difference, I'm still seeing quite deviation from that. It's moving quite far. So the same example with this person, when Devensby was suspected of murder, when they found a murder weapon, right? How likely is it that I will see a murder weapon in his home, given that he is innocent? It's very, very unlikely. If he really is innocent, I should not be finding this in his house. Does this prove he's not innocent? No. Just because there's a murder weapon in his house, it does not prove he's innocent or that he's not innocent. Yes, that's a very good way of putting it. How believable the t value is. That if I'm getting, okay, mujhe ye difference mila, I got this difference. How can I trust you? How can I trust you? Same with Devensby. When you found murder weapon in his house, how can you trust him? You're going to suspect him now. You can't really prove that he's done the crime, but you're still going to suspect him. What makes us trust p value? Because it's the probability. the p-value is not doing something inherently untrustworthy. If you want, you can look at it. It contextualizes for the data problematic. Yes, exactly. Okay. So that is the basic idea of p-value. That what is the likelihood of me seeing this difference or some difference or something more extreme given that the null is true. Or if you want me to put it in, let's say, if I want to give you a simpler example. Okay. Let's make this interesting. Let's make this fun. Let's understand this properly. Let's say that I have a person over here. Okay, let's call her Jane. Okay, Jane is dating. We're gonna give him a very cheater boy kind of names. So I'm sorry if there's anyone over here with this name. I don't mean it in a bad way. Okay, Jane is dating Rahul. Fine. Now, if the null is true, since we say given, what makes having a difference true too? The difference is not true in the sense that the null is true. The null is assumed to be true. The difference is not proven to be true or assumed to be true. Okay, coming back to our explanation of this. So Jane is dating Rahul. Okay. Now Jane has found uh, uh, his Rahul's phone. She's gone through his phone. Okay, and she has found a dating app installed. So far, what has Jane been believing? She believes that he's loyal. So the p-value is very simply like, what is the likelihood of me seeing a dating app on his phone, given that he is loyal? If he's loyal, he should not have it. It's very, very unlikely that he's going to have a dating app installed. Zero. It's very, very unlikely that it should have. This person should be have a dating app installed. He should not. Yeah. It's very, very. If you're loyal, it's very, very unlikely. Does this prove he's not loyal? No. Does not prove he's not loyal. I mean, uh, it's not like that's going to save the relationship, but it does not prove it. Okay, from an academic point, it does not prove it. I can see that it's like bringing up like bad memories and stuff for people. Like damn, real hoga. Okay, Rahul. So it does not prove that he's not loyal, but it's very, very unlikely now. Right? That is what the p-value is doing. That what is the likelihood of me seeing something like this, a dating app, given that the null is true? What is the null hypothesis? That he's loyal. Right? That is the status quo, the basic assumption that this person is loyal. Does this prove that he's not loyal? No. But now I'm not going to be able to trust you because why is this on your phone? Let's say that what's the likelihood of me seeing this person, Rahul, walking with some other girl, given that they are loyal? This is okay-ish scenario, right? Might be a sister, might be a friend only. Not that unlikely. What is the likelihood of him, let's say, buying flowers, buying flowers, given that he is loyal? Now this could be for you as well. So this is not raising any red flags. So this is fine. It's quite likely. If he's loyal in a relationship, he will be doing something like buying flowers, buying chocolates or whatever for his girlfriend or something. So this is the basic logic behind p-value. That what is the likelihood of this one thing being seen by me, this extreme thing, given that the null is true. So if this guy is loyal, right, which is our null hypothesis, our red zero is he is loyal. So if he is loyal, the likelihood of him having a dating app should be low given that he is loyal. This is it. This is all that a p-value is. So the same thing that we do for our data, right? The likelihood of me seeing this p-value or this data or this effect, right? Let's say men scoring more than women on something or women scoring more than something on some other score should be greater enough for compared to the, let's say, null. Let me just put h0 over here. Sorry, I mean lesser than. Yeah, that is how it makes sense better, which is why I had to switch to that example. So if this is my data, it becomes less likely that I'll, see something like this given that the null is true. So if this guy really is loyal, it should be less likely for me to see a dating app on his phone. Similarly, it is less likely for me to see such a difference or such an effect given that the null is true. You're seeing here why I'm saying that the assumption of the null is true, because you assume that they are loyal. You don't have any reason in normal healthy relationships. You assume that the other person is loyal to you. You don't go out thinking if they are loyal. I mean, in the early stages, yes, that does happen. But usually, when you're dating someone for a while, you won't say if my partner is loyal, he'll do this. Yeah. So the null is like a reference point. So it's more like, oh, the assumption is that it's the null, it's the status quo, right? I won't every day think if my boyfriend is or if my girlfriend is loyal to me. No, it's quite likely. It's a true thing. It's a fact to me that they are loyal. So if I see a dating app on them, मुझे तो धक्का लगेगा. I will be like, damn, what the heck is this? The null is like a reference point. Yes, we will reject the null in that case. He's not loyal. Yeah, I will not comment on that. Okay, but is p-value clearer now with this example? Does it make sense? Yes. Okay. That's what a p-value is. So if you ever feel like you want to interpret p-value properly, just remember a guy cheating on a girl. Okay. Or a girl cheating on a guy, whatever it is. You'll remember it much better. You'll be like, what is the likelihood of me seeing a dating app on this person's phone, given that they, are loyal? And you just remember the whole concept. Okay. Now, quickly, we'll go over the different types. There's an independent t-test, which you might be familiar with. Basically, there's two different groups. One is diagnosed with ADHD, for example. One is a control. They can't be, they always will be exclusive. This one group will always be separate. You can't have one group have like schizophrenia and then put them again in the control also. Like, oh, no schizophrenia. You can't do that. So these will always be two separate groups, right? And we come back to the same thing. Effect over error, how good the model is compared to how bad the model is. So this is usually the formula for it. We won't calculate today, but you can see here, right? Mean of the two groups divided by the standard error of the difference. This is together, this whole thing is called the standard error of the difference. Why? Because this is the first mean ka standard error and this is the second mean ka standard error. It's thoda modified over here. It's not exactly the same. They've modified a little, but it's the two groups ka standard error being added up. So if I take the wiggle room, right, because that's what the standard error is, the wiggle room of the first group and the wiggle room of the second group, and I compare it to the mean effect, to the mean difference, right? Which is louder than this or this? That is the whole point of a t-test. Which is louder? Is it the standard error of the difference or is it this? Let me think of an example I can give you for this. Let's say that we have I'm thinking. Let's say we have two groups over here. Okay. And we've taken their mean. Mean of one group, mean of the second group. Yeah. The wiggle room, not wiggle rope. Wiggle room. Room. You know what a wiggle room is? How much space you have to wiggle around. Right. So the way this works is we are just taking a difference of the mean, the way we had done before, right? The 203 minus 198. Then we are comparing it with the standard error of the difference of standard error of this guy added with standard error of this guy. It's modified a little bit, but you can see it looks pretty similar in idea. Because I want to see that the noise combined from these two, is that loud enough or is this effect loud enough? So if this is small, the standard error, even if someone whispers, right, even if the effect is just whisper, it'll still give me a t value that's big. And if the t value is big, my p value becomes smaller. So that is the basic idea of what a t-test is doing. It's comparing the effect and it's checking it against the noise, against the wiggle room, ROOM, room. A paired t-test is also has a very similar formula, but it is slightly different in the way it works. You have basically one group that goes through two conditions intervention. This is very commonly used in therapy related intervention related studies, very commonly used, because you're comparing that, okay, before CBT मैंने ये किया, your scores were this, your anxiety, and after CBT your scores were these, and we're comparing, is there a difference? So same logic, mean before, pre, mean after, post, and standard of the difference. Same thing again. This also formula looks slightly different, but not something you should be worrying about right now. So same logic as before, how good the model is versus how bad the model is. Effect over error, you'll keep seeing this time and again everywhere we go. And p-value, what is the p-value? Tell me. Now you guys tell me. Let's say that I get a p-value of 0.8. Sorry, a t-value. I'm sorry. A t-value of 0.8. What does this tell me? What can I infer from this? What would this tell me? Very likely. Yes, it's very likely for me to see such a value. Very good. It's very likely for me to see such a value given that the null is true. Okay, what if I get a value like, let's say, 9, a t value of 9? What would that mean? Unlikely. Let's say I'll put 9 over here. Okay, so how likely is it for me to see this bigger difference? This big a difference given that my null is true? Unlikely. I'll put very unlikely for me. Okay, what if I get a t value of, let's say, 4? What then? Unlikely. Is it more unlikely than the 9 one? Less. So you will see usually that in most studies, if the t value, right, crosses 2, in most cases 2, 2.5, this around here is where it crosses 0.05. And above it, somewhere around, let's say 3, 4, 5, here it becomes 0.01. And then it keeps getting smaller and smaller, like 0.001, etc. It keeps getting smaller as you keep going. Same for the other side too, but I'm not touching that for now but it's the same logic. That's not really important. So is t value, t test, p? Unlikely means due to chance. Kind of. Actually, no. I mean, it's not due to chance. It's the other way around, that it's not due to chance. In the sense that it's unlikely for me to see a difference this big just by chance. Or, if the null is true, given that the null is true. ऐसा दिखना नहीं चाहिए. I should not be seeing a difference like this or a difference this big given that the null is true. So the 95% error or the 5% chance, actually I would recommend not using those terms only. Avoid those terms because they've been diluted, they've been taught in a horrible way. Just ignore those words. Yes, in that case, you would reject the null. The second it crosses this threshold of 0.05, we reject the null. If it's less than 0, if it's greater than 0.05, what do we do then? What then? Very nice. We fail to reject the null. Yes, we can also say that we reject the alternative, or very simply, we retain the null. We never say we accept the null. We say we retain the null, or fail to reject is actually a better way to say it. Yes, good job, Alan. Fail to reject is a better way to say it. So we retain the null. We never accept it. You can't accept the null, but we retain the null, or we fail to reject the null. Okay? Is this much clear so far? Any doubts so far? Because we are at the end anyway, we're done for today. We've covered properly p-values, we've covered t-values properly. Because if these two are clear of what a test statistic is, right? The t is a test statistic. The p-value should be p for probability, right? The t-value is what? A comparison, right? A standard comparison given to the noise, right? And based on that, we get the probability of me seeing such values given that my null is true. So this is the p-value. So the p-value should be less than 0.05. What is the reason for that? For not saying that? Because you can't accept the null, right? Say I'm saying that there is no difference between men and women in, let's say, on depression. Men and women are the same. So if I'm taking it as my H0, my null, I can't accept this, because just because I fail to find evidence for it does not prove this. Does not prove it. So if I'm saying I accept it, I'm saying that I'm proving it. It does not. Right? Same thing that we had seen with this guy also, right? He was we found that, okay, the probability of having a dating app, given that you are loyal, right, is pretty low. It's pretty low. Dating app on phone, given that he's loyal, is pretty low. But okay, let's say that I found that he was buying flowers, given that he's loyal. So this does not really raise any red flags for me. It's not that low. This probability is not low. If he is loyal, he will buy flowers. But this does not prove that he is loyal. It does not prove that he is loyal. For all we know, he might not be loyal. You've seen the difference. How does one find the p-value? How do we find the p-value? We get the p-value by looking at the critical tables, right? You'll see the table. I'm not sure. One second. Let me see if I can find it and show it to you. 1 second. If it's there, I'll show it to you right now only. These tables help you to interpret the table. Okay, it's there. Yeah. Let me share my screen. Let me just show this to you in like a minute, and then I'll give it over to Snell. Look at this. You'll get a table like this, where on the left side you have the degrees of freedom. Degrees of freedom I'll cover later, some other day or something. But for now, the degrees of freedom, and on top you have the significance value at one tail and two tail. Let's say we want to check at two tail at 0.05. So what I would do is, for my study, what is my degree of freedom? Let's say I had a sample of 25. No, let's say it was 25 minus independent group, no, n minus 2. So 23. So I'll come to 23 over here, and my critical value is 2.069. So if my t value, okay, t value is greater than 2.069, it means that it is less than 0.05. In fact, in my case, it's less. It's the value was what, 2.5. No, so over here you can see exactly 2.5. Exactly 2.5. So that just means that it's at 0.01 level. Again, we don't use these tables anymore because most software just directly give you the t value. But this is how you interpret it. Does that make sense? Yeah. Awesome. Okay. So that is all for today. I think if I have one more class with you guys, I'm not sure if I do have to check the time, the schedule. But if I have one more class, I'd like to cover a little bit of factor analysis. And I'll have to see if I have one more lecture. If not, we'll cover them in depth. But this is the general idea so far of what we've done with stats of mean, standard deviation, variance with standard error, uh, a test statistic. Today, I took t-test as an example of a test statistic and p-values. Once you have a decent understanding, even correlation and regression, once you have a decent understanding of this properly, if you want to go over and watch the other lectures again, but once you understand these properly, it becomes easier to understand all the bigger tests, right? ANOVA, ANCOVA, two-way ANOVA, factorial designs. It becomes so much easier because an F test is just the same thing. It's pretty much the same thing. In fact, you know that linear regression and t-tests are practically the same thing. Yeah, think about it. It'll break your head a little. If it'll break your mind a little bit, but you can technically run. They're not the same thing exactly, but it's like you can run a t-test using regression. Yeah, it'll break your mind if you think about it, but it's actually very cool. But this is the basic idea that you have your standard deviation, your variance, your mean, and we're comparing them. We're seeing what is the effect. We're comparing it to a noise, and we're seeing what value we get, and we're seeing how likely it is for me to see such a value if my null is given that my null is true. And these are the core ideas of statistics. Okay. Any doubt so far before I give it up to Snell? Yes, no, maybe. Okay, that's someone raised their hand. Okay, awesome. Do you want like a 2-minute break? Yes, go take a 2-minute break and then Sarah, you can stop recording. Thank you. You can take a 2-minute break. After that, Snehal will start. Snehal, you can take till 8:05, 8:86, 8:05, 8:6, and then I'll come back for the announcement. Wait, let me make you host.
Hello, hello.
Hello. Give them a minute. They'll come back. They'll drink water and stuff.
Yes, yes. Done, done.
Sarah will not be able to record because she has to go for a meet.
I can record from here.
Snehal will record. Yeah, not a problem.
हाँ ठीक है ठीक है We'll start in a minute, okay? Okay, let's begin. Chalo, how are we doing? Did you all have tea, coffee, whatever that you guys consume to keep yourself awake? Oh, that's great. That's great. I am glad that you're liking biopsychology. The thing about this subject is that uh, we keep on associating it with uh, core sciences. I mean, it is a part of core science, but it's not supposed to be that difficult. If we make it relatable, uh, it's extremely fun. It's just very, very jargon heavy. So, like I've mentioned it before also, for you to study biopsych, you actually have to say things out loud. Just reading it, underlying it will not make sense. You should be able to say those words out loud. You should be able to pronounce it properly. Uh, and while studying neuropsychology, it is always a great idea to, have a pen, paper, or stylus, tab, whatever you use, and engage all your senses while studying neuropsych. Especially, like, there has to be something visual so that you don't get bored. There has to be something auditory, so when you are studying on your own and when you're saying things out loud, it's going to help register things quickly, and at the same time you're actively writing things, so you're aware of the spelling. While you're studying, you can very roughly draw diagrams the way I do here on the PPT. I think that makes biopsych much more easier, according to me. Yeah. If you all have questions, I think you can send it over to Shannon, and then he can pass it over to me. Okay. Biopsych made you realize that you're a bad artist, Khushi? What are you saying? I don't think so. See, I am actually a very good, I am very good at painting and drawing. Okay. Do not judge me on the basis of this drawing that I do on the PPT. It's just the stylus. And obviously the amount of time that we have in hands. I think, Khushi, with you, it will be the same. If you put your heart and soul into it, you will be able to do a good job. And it's fine as long as you are able to understand that an eye is an eye and an ear is a ear and a neuron is a neuron. I think that's that. We don't need to be Picasso. Okay, chalo. Let's get started. Are all of you here? Quickly give me thumbs up and then we will begin. हाँ एग्जैक्टली तुमको एंट्रेंस में ड्राइंग किधर करना है करेक्ट हाँ चलो लेट्स गो फाइन अभी आज हम इतना ज्यादा रिवीजन नहीं करेंगे बिकॉज वी हैव टू कवर अ लॉट ऑफ थिंग्स टुडे वी आर गोइंग टू डू ओवरव्यू ऑफ द सेंसरी सिस्टम. I am going to focus more on the auditory and the visual processes, because that is what usually questions like this, that is where questions usually come from, and we don't have so much time. But I will be also touching briefly upon the kinesthetic sense, the vestibular sense, the tactile, olfactory senses, etc., etc. ठीक है, तो हमें ये सब कवर करना है, तो पहले के लेक्चर्स का रिवीजन हम बहुत क्विकली करेंगे, ठीक है। फर्स्ट वी टॉक्ड अबाउट द स्ट्रक्चर ऑफ न्यूरॉन्स एंड देन वी स्पोक अबाउट हाइपोपोलराइजेशन, डीपोलराइजेशन, एक्सेट्रा एक्सेट्रा. I have kept the chat box open. Quickly tell me, what is depolarization, what is repolarization, what is hyperpolarization? Yes, yes, I'll start recording. Thank you, Jennifer. I had completely forgotten about that. Okay. This call is now being recorded. This call is now taking notes. This call is now being transcribed. Okay. Yes. Now quickly tell me, what is depolarization, repolarization, hyperpolarization? Yes, repolarization is repolarization is not refractory period. Hyperpolarization is refractory period. Absolute refractory period. Why? Because now the inside of the cell has become so negative, अभी फिलहाल के लिए वो कुछ नहीं कर पाएगा. जैसे when you are done with my biopsych class and उसके बाद अगर stat का क्लास होता है, तो तुम लोग कैसे बोलते हो कि oh my brain is fried now, it's completely saturated now, I can't deal with anything anymore, I need a break. So वैसे ही तुम्हारा न्यूरॉन ऐसे अंदर से पूरा नेगेटिव हो जाता है, तब it's like okay wait, I can't do anything anymore, give me a break. That is hyperpolarization and that is absolute refractory period. Okay. Depolarization, yes, is when Nora the Explorer is chilling. She's at rest. Correct. Perfect. And then repolarization is inside is more negative than outside. Correct. Perfect. Yes, yes, yes. So this part is clear. The number should be clear. Chilling is -70. Then thoda activate hona start ho jata hai at -55 MB. Sodium channels are going to open. Perfect. Then at +30, there is action potential spike. Then we have repolarization and then we have hyperpolarization. Yes, perfect. Next, we had a look at our central nervous system and we did all of these things, right? Telencephalon, diencephalon, mesencephalon, metencephalon, and the spinal cord. We're not going to go too much into detail here. Okay, this table you must remember. And we had spoken about the meninges, and we had spoken about the CSF and how the CSF flows through these ventricles. Yes? Do we remember that? Give me a thumbs up. Very good. Chalo. So let's continue with our lecture series today. Our Nora the Explorer is now going to look at these 5 senses, because now she's realized, acha, there are 5 doors, and she's going to open each one of the doors, quickly peep in and come out. Okay. But now you know the drill. Before we start the lectures, we start with MCQs. So let's quickly respond. Which part of the brain is primarily responsible for processing touch sensations? Correct. It's C. Very good. Next. Which sensory system is most directly responsible for maintaining balance during motion? Perfect. Perfect. B. Next. Which structure detects rotational movement of the head? No, it's not cochlea. No, it is not incus either. Wow, only one person has given the right answer. Oh no, now many of you are giving right answers. Okay. Yes, it is C, semicircular canals. Okay. Like I said, it's fine. These set of MCQs are just for us to understand where we are at, so that I can start teaching from there. Okay. Next. Free nerve endings are most associated with. Correct. It is B, pain and temperature. Very good. Next. What makes vestibular hair cells fire action potentials? Alisha, free nerve endings क्या होता है? I will teach in the lecture. Don't worry. The answer is B, correct. Pressure from fluid movement. All of this we'll learn in today's lecture, so don't worry for those of you who did not get the right answer. Okay, chalo, cool. So let's begin. Fine. Now I'm closing the chat box. ठीक है, अब मैं बीच में when I'm opening the chat box, I'll tell you, and then you can ask me whatever questions you have. Now I'm not going to check it. ठीक है? चलो, let's begin. Okay. Now you saw our Nora the explorer, and imagine that she's wandering in the hallways of your brain. Okay. And अभी उसको धीरे धीरे पता चल रहा है ना कि मैं अकेली नहीं हूँ. There are so many other neurons with me, and oh, there are different parts of the brain. So अभी in this hallway, now she stumbles into this massive chamber with 5 grand doors, which I just showed you. You know, and each of these doors leads to a different sensory system. तो अपना नोरा का क्या जॉब है? The Nora's job is to carry messages from each sense, transmit them to the brain, and help the body respond appropriately. Right? Not just Nora. I mean, Nora like is the representative of all the different kinds of neurons. So let's dive into that. So at the heart of our perceptual experience, okay, lies a very sophisticated infrastructure, which is basically a sensory system. And each sensory system is specialized in transducing a different form of environmental energy into electrical impulses and feeding it forward for central integration. Now, there are too many words here. Okay? We used terms like transduction. We used words like electrical impulses and central integration. Okay? So what does all of that mean? For us to understand that, let's quickly have a look at what is a sensory system in the first place. Okay, a sensory system is obviously a part of the nervous system that first detects stimuli. Okay, stimuli from where? From the environment. So environment, matlab light, sound, chemicals, pressure, temperature, all of these are different kind of stimuli. So a sensory system basically detects stimuli. Second, it transduces it into neural signals. Okay. Now, does anyone know what transduction is? Does anyone know what transduction refers to? Have you ever heard about it? Okay. Transduction basically is the process by which any form of physical energy matlab kya? Light, sound, pressure, any kind of chemical, temperature, all of these are physical energies, right? So transduction is the process in which physical energy gets converted into electrical signals. Okay. Because brain can only interpret electrical signals. ठीक है, तो ऐसे समझो कि नोरा द एक्सप्लोरर अपनी जो फ्रेंड है, she doesn't understand light, sound और smell as it is. ठीक है, तो उसको समझने के लिए हमें एक्सटर्नल स्टिमुलाई को न्यूरल लैंग्वेज दैट इज इलेक्ट्रिकल इंपल्सेस में कन्वर्ट करना पड़ेगा, so that Nora and her friends can carry it to the brain. Okay, so that is transduction. Now, like I said, first sensory system will detect a stimuli. Second, it is going to transduce it into neural signals. Third, it is going to transmit these signals to the brain. ठीक है, via sensory neurons. ठीक है, then it is going to interpret them. ठीक है, the sensory system is going to interpret all of these signals which it has gotten. And interpretation happens where? It is going to happen in the cortex. Correct? Now, it is very, very important for us to remember that sensation and perception are not the same. ठीक है? Think of it like this कि sensation अगर raw input है, ठीक है? तो perception is the brain's constructed output. So sensation is nothing but you detecting that stimulus exists. So right now when I'm looking at you, I am able to see, acha, there is a laptop. My camera is on. If I open the chat box and I'm able to read messages, just the sight of it is the sensation. I'm detecting the sensation, right? So detecting the stimulus. Now, when I'm reading it and when I'm responding to it, that is because my brain interpreted that stimulus. Are you getting it? So sensation and perception are different things. Sensation is the detection of stimulus. Perception is brain's interpretation of that stimulus. Okay. Now, like I said, the sensory system is how we perceive and interpret the world. And that happens through specialized organs and neural pathways. So the 5 major senses are your vision, audition, touch, taste, and smell, along with your vestibular system for balance and proprioception for body awareness. Okay? Now, let's dive into the visual system first. Now, look at this diagram very carefully. I'm sure all of us are pretty much well versed with this because हमने 10th में भी ये किया है. Those of you who took science in 11th and 12th, we've done that. This there also. FY also in psychology, we've done this. If you are in your master's right now, you must have done this in neuroscience. So let's quickly walk through this. Okay? Now, we first start with the cornea. Okay? Your cornea and your lens basically help focus light on your retina, which is here. Okay, this entire part is your retina. Okay. Now, the light enters, and if you see here, there is lens and there's pupil here. Okay. Now, tell me one thing. The black part that exists in each of our eyes, that is pupil, right? Can you respond in yes or no? The black part, the small dot. So, all of you who are saying yes are right. The black part, the black, the whole thing, okay? That is your pupil. Okay. Now, one of you mentioned the term iris. Iris is basically the colored part of the eye. Okay. So, iris is basically here. This is the colored part of the eye. So some of us have brown eyes, some of us have blue eyes, black eyes, right? That is iris. And the black dot that all of us have, that is your pupil. It is basically a hole, okay? And what does it do? It allows light to enter the eye. And what does iris do? Iris controls the size of the pupil. Okay? So, your iris is basically responsible for regulating how much light is going to enter the eye. So if it is too dark outside, what happens? Your pupils dilate. If it is too bright, your pupils are going to constrict. So all of that happens because of your iris. Okay, are we clear about this? Yes, pupil actually is not a structure. It is basically a hole inside your iris. Okay. Now, okay, someone has asked, can you explain why it's called transduction and not transformation? See, basically, transduction comes from the Latin term. It is a Latin term. Okay, so trans basically means across or through, and duction part means to lead or to carry. So transduction literally means to lead something across. So what is happening here? We are carrying the physical stimuli into a neural format, right? So that is transduction. Transformation क्या होता है? Transformation is change in form or appearance. So if we use the word transformation, it is going to be too vague, right? But transduction is an actual conversion of energy across systems. That is why we use the word transduction. Okay, fine. Now coming back to the visual system. Now I'm not looking at the chat box. Okay. So yeah. So we are done with the cornea, pupil, lens. This part is clear. Now there is something known as aqueous humor right here. Okay. And there is something known as vitreous humor here. Now there is a reason why these are two different things. They are not extensions of each other. Okay. Now what does aqueous humor do? Aqueous humor basically helps nourish that part of your eye. Okay, the one that comes before your lens. Okay, this aqueous humor, which is in the front chamber, it is a very watery liquid. That is why it is called aqueous in the first place. Aqua means water, right? It is very watery. Whereas when you talk about the vitreous humor is not watery. It is very jelly-like. Okay, so that is why these two things are very different. Aqueous humor is between your cornea and it is between your lens. Okay, the consistency is very watery, it is thin, it nourishes your cornea and lens. Okay, and another thing is that if there is any kind of damage that happens here in this part of the eye, if there is some damage to your aqueous humor, then you are going to be experiencing something known as glaucoma. Okay. Again, those of you who watch Grey's Anatomy or House MD, you might have heard of this term very frequently. Okay. Now, what does vitreous humor do? Vitreous humor is something that lies between your lens and your retina. And like I said, it is very jelly-like. It is very thick. Okay. And what is its primary function? To maintain eye shape. That is why it is jelly-like. Imagine if it was water-like, then your eyes wouldn't have been able to be in place. It needs something semi-solid sort of a thing to keep it in place, keep the retina in place, keep the eye in its socket. Okay, and so that is main thing that you need to keep in mind. So vitreous humor keeps the retina stuck to the wall. Okay, and aqueous humor basically is in the front of your eye, which basically nourishes your lens and your cornea so that the light can pass through it properly. Okay. Uh, Now, the main important part of this, which is your rods and cones. Okay. This part, like I said, is your retina, and your retina contains photoreceptors. Okay. Sorry, just a minute. It contains photoreceptors. Photoreceptors are nothing but your rods and cones. Now, what are rods? What are cones? Can someone quickly tell me what do rods do and what do cones do? Which one of them is for dark vision and which one of them is for light vision? Correct, correct. Now, the way I like to remember it is that when you're eating ice cream, ice cream has different flavors, it has different colors. So if I am eating a cone, it is going to have different colors, right? So cones meaning color vision. Okay. Rod matlab, imagine like if there is complete andhera in your house, there is no light coming whatsoever, and you're alone in your house, okay, and you detect some kind of movement, and now you're scared that, oh my god, who's in the house? There was no one supposed to be here, it was just me. So when it's too dark and when you detect some movement, you're going to take a rod in your hand, right, to protect yourself. So remember it वैसे. Rods matlab dark vision. Okay. And I mean help you in dark vision, night vision. And cones, color vision or daylight vision. Okay. Keep that in mind. So now rods are going to be in the peripheral retina. Okay. Rods in your peripheral retina. Okay. And your cones, they are going to be concentrated in the fovea. Okay. Now, what is the visual pathway going to look like? Again, I have to cover this very quickly, so I might not be able to go into detail. Try to pay attention, okay? Because we have to cover other senses as well. Now, the pathway is going to be something like this. Light hits your retina. Just a minute. Why did my stylus stop working? Huh. Light hits your retina. From there, it goes to your optic nerve. Okay. First, write this down. I'll show you. I've put diagrams here. So, आगे तुम लोग देख लोगे. Right now, just write this. First, light hits your retina. Then it goes to the optic nerve. Then it goes to optic chiasm. Okay. From there, it goes to your LGN, lateral geniculate nucleus, that we had spoken about last time. Sorry. This is in your thalamus. Correct? And from there, it is going to go to your visual cortex. Okay. This is basically the process. Light hits your retina. Retina से optic nerve से optic chiasm से LGN से primary visual cortex. ठीक है. Now, we also need to talk a little bit about the way our rods and cones exist, okay, inside the retina. So look at this diagram. Okay. I told you about the optic nerve, right? Our optic nerve is here. These are our rods and cones. If you see, cones are literally cone shaped, rods are very rectangular. Okay. Now, these are your ganglion cells. And these are your bipolar cells. Okay. Bipolar cells क्या करते हैं? They connect your photoreceptors, that is, they connect your rods and cones to the ganglion cells. And what do ganglion cells do? Ganglion cells के जो axons होते हैं ना, they bundle up together and they form the optic nerve, which you see right here. Okay. So what I said, retina उधर से जाएगा optic nerve पे. ठीक है. Then it will go to optic chiasm. Now, optic chiasm is here. Okay. Now, what does optic chiasm do? Optic chiasm is the place where things start crossing over. Okay. So, if you see, there's a crossover right here. So, it is a midline structure at the base of the brain. It is just above your pituitary gland. And this is where the optic nerves from both eyes partially cross over. Okay. So if you see the nasal or the inner half of each of the retina's fibers cross to the opposite hemisphere, and the temporal, this side, temporal outer half of each retina's fiber stay on the same side. Okay, so this way what happens? The right visual field of both eyes goes to the left hemisphere, and the left visual field of both the eyes goes to the right hemisphere. Okay? And why does this happen? Because your brain processes visual information contralaterally. Contralaterally means on the opposite side. Okay. So again, this was the pathway that we talked about: retina, optic nerve, optic chiasm, LGN, and visual cortex. We looked at what the optic nerve looks like, which is right here. And then we looked at what optic chiasm looks like. Then we have LGN, and then we have the primary visual cortex. Okay. Are we clear about this? Now, there is also something interesting known as the dorsal stream and the ventral stream. Now, what is that? Dorsal stream is also known as your Ware pathway. Okay. And your ventral stream is also known as your Watt pathway. So basically, when we get visual information, that visual information not only goes to your occipital lobe, but it also goes to your parietal lobe and temporal lobe. Your dorsal stream, which is your where pathway, is basically located in your parietal lobe. And your ventral stream, which is the what pathway, is located in your temporal lobe. Okay. Now, the dorsal stream helps you in motion. It helps you detect depth. It helps you with spatial navigation, and it helps you with object tracking. Whereas the what pathway, the ventral stream, which is located in your temporal lobe, helps you with object and face recognition. Like, what is the object that you're looking at? Who is this person that I'm looking at? It helps you detect color. It helps you with complex shapes. Okay, so that is about your visual system altogether. So far, any doubts? Fine. So now we'll go ahead with our auditory system. I know the visual system and everything might seem a little rushed, but that is because we have to finish the overview of all our senses. Again, when we start lectures in depth, तभी हम एक system एक lecture में लेंगे. Right now, I just want to give you an overview. Now coming to the auditory system. Now, you must have done this in physics if you had taken science in 11th and 12th. Or 10th may also you must have at least been acquainted. I think you must have been taught this a little. There are certain things which you need to know, something like certain terms like wavelength, amplitude, frequency. Okay? So imagine if this is what our wavelength looks like. Okay? Then this part, the height or the distance between this line and this, okay, is basically your amplitude. Now, this entire thing, okay, how frequently each wave is coming is basically your frequency, the number of waves that pass a particular point per unit time. Okay. So if I draw something like this, it means high frequency. If I draw something like this, it means low frequency. Are you getting this? And what is wavelength? Wavelength is basically this part. Wavelength is the distance between identical points on consecutive waves. Okay, so this is one wave and this is your second wave. So if I take the midpoint of both these waves, this distance is going to be the wavelength. Okay, so amplitude is the height, wavelength is this, and the entire thing is going to be the frequency, the number of waves that can be fit into one particular line, just to make it simpler. Okay, and what is speed? Speed is basically your wavelength into frequency. Okay, keep this in mind. Now, basically, when you think of sound, sound is nothing but changes in air pressure over time. Okay? And when you talk about sound, these are the three physical dimensions which we just spoke about. There is frequency. Frequency is measured in hertz. Okay? It is basically the rate of vibration. Okay? And it is usually perceived as pitch. Then we have amplitude, which is basically measured in decibels. It has to do with your intensity of vibration. Okay. And it gets perceived as loudness. Then you have complexity. Complexity is basically the number and the variety of waveforms. Okay. So for example, if I am listening to now people who have watched The Office, if you listen to the OG title track, okay, the the one which we hear. Now it has many musical instruments, right? Whereas if you go on YouTube and you just type the Office title track, the keyboard version. Now, even though both of them sound the same, like you can understand कि हाँ ये दोनों Office का ही चल रहा है title track, but you can't tell the difference between the two, right? Why is that? Because the variety of waveforms and the number of waveforms are different, and that is basically perceived as timbre. Okay, so flute versus violin versus keyboard, and when all of them come together, it is going to sound different. So that is complexity. ठीक है, so sound के ये 3 physical dimensions है which you need to keep in mind. Now that we've understood the nature of sound, let's understand how do we process it. So this is your auditory system, this is your pinna, the outer ear. ठीक है, this is your auditory canal. Then this part is your eardrum. So basically when you put on earphones, our mothers or our parents usually say, no, इतना time क्या earphone कान में रखा है, तुम्हारे कान के पर्दे फट जाएंगे. That कान का पर्दा is nothing but your eardrum. Okay. So then you have your semicircular canals, which are right here. Then you have ear ossicles, which is Malleus incus stapes. Okay, these are your ear ossicles. Now, these semicircular canals basically form your vestibular system. So अभी हम इसके बारे में बात नहीं करेंगे because we are talking about the auditory system. Auditory system will have your Malleus incus and stapes. These are collectively called your ear ossicles. Okay, and this is your auditory nerve, this is your cochlea, and this is your eustachian tube. Okay, now basically what happens is that your outer ear will first capture, your pinna will first capture sound waves. Okay, now in this auditory canal, this external part of it, this part, the external auditory canal is going to channel and slightly amplify these sound waves to the tympanic membrane, which is your eardrum. Okay, then we come to this is where your middle ear begins. Now your tympanic membrane, your eardrum is going to start vibrating when the sound hits. As soon as the sound hits the eardrum, immediately your 3 tiny bones, which is your Malleus incus stapes, they are going to start mechanically amplifying vibrations. Now, if you see stapes is right here in the end, right? Stirrup. Now it is going to press on the oval window of the cochlea. Your cochlea is here. This is where your oval window is going to be. So it is going to press on the oval window of the cochlea. And once cochlea is what basically? Cochlea से तुम्हारा inner ear start होता है. So cochlea is this snail-shaped fluid-filled organ of hearing. Okay, and your cochlea houses your basilar membrane. Okay, and your organ of corti. Okay, what does organ of corti do? Organ of corti basically sits on your basilar membrane and it contains your, basilar membrane जो है उसके ऊपर there is organ of corti. Okay, and your organ of corti basically contains hair cells, which are nothing but your auditory receptors. Okay, so remember we had spoken about transduction. So your hair cells basically transduce all these mechanical vibrations into electrical signals via the bending of cilia. These hair cells are called cilia. Okay, so basically how do the sound vibrations travel? They go from your outer ear to your middle ear to your oval window, then sends these vibrations to your cochlear fluid, which then hits your basilar membrane. And on your basilar membrane, is your organ of corti, which has cilia, which are basically your auditory receptors. Okay? So now let's look at the entire process again with the help of the diagram. This is the sequence of events. First, the sound is heard, the sound is created, then your pinna is going to capture all of that. Vibrations are going to enter your auditory canal. Once the vibrations enter your auditory canal, it is going to hit your eardrum. Now, once it hits your eardrum, then your ear ossicles, mealis and stapes are going to start moving. Okay, and while this is happening, amplification of sound is also happening. Okay, then these vibrations get transferred to the oval window by stirrer because it is the last thing, right? Then the movement of the oval window is going to create vibrations in your fluid of the cochlea. After that, it is going to go to the basilar membrane. Basilar membrane से vibrations होंगी in your hair cells. Okay. Then, because of the bending and distortion of the hair cells, that is basically going to cause a nerve impulse. Okay. And then it is going to pass along your auditory nerve. Are we clear with this? Yes. Difference between complexity and timbre, it is not different. Complexity is perceived as timbre. Yeah, what doubt do you have about speed? You mean the formula? Speed is equal to wavelength into frequency, is what I had said. Okay? All right. I mean, see, technically it should be easy only. Speed is equal to, what? Can you show what inner ear looks like? I don't have the diagram here actually. But you can Google it. Or if you want, I can Google it and I can send it to you through Shannon, if that's fine. All right? All right. Okay. Let's go. So that's about your visual system and your auditory system. Now let's quickly talk about other senses. We have very little time. So I'm going to quickly walk you through this. Okay. So you have your tactile sense. Tactile sense is basically activated when the skin experiences pressure, vibration, temperature, any kind of change or injury. Okay. And there are specialized receptors under the skin which detect these sensations. So what are the types of sensations? There is pressure and or vibration. Now, pressure or vibration is usually detected by mechanoreceptors. Okay. Like the Meissner's or the Pacinian corpuscles. Okay. Then we have then we have temperature. Okay. Temperature is basically detected by free nerve endings that sense warmth or cold. Okay. Then you have pain. Pain is detected by nociceptors. Okay. Nociceptors usually respond to harmful or intense stimulation. So basically, how does your brain understand touch? The strength of the touch is equal to how much the receptors get activated, and the location is what through which brain understands touch. So two things: your strength and the location. So how does the brain understand touch? Through the strength of the touch and the location as to like where the receptors are on your body. So if you notice, areas like your fingertips or your lips have more receptors. They are more sensitive. Okay. So your touch begins in the skin because it has the receptors for pressure, texture, vibration. And these signals travel through the spinal cord to your somatosensory cortex. Okay. And this somatosensory cortex is in your parietal lobe. And different parts of your body are going to have different kinds of sensitivity based on how many receptors they have. So, like I said, fingertips are more sensitive than, let's say, your back. Okay. And so yeah, that's about your tactile sense. Like very quickly, I'm walking you through this. Then you have the gustatory sense. Okay, gustatory sense is basically your taste. When does that happen? When the chemicals in your food dissolve in your saliva. Okay, and they get detected by taste buds. Okay, these taste buds are on your tongue. And what are these taste buds basically? These are nothing but these are very visible bumps on your tongue. uh, there is something known as papillae, okay, which are the visible bumps on your tongue, and your taste buds are inside of them. Okay, and each taste bud has many receptor cells that respond to different taste types. Okay, now the primary tastes which we need to keep in mind uh, are sour, bitter, umami, sweet, and salty. Okay, now all of these each taste corresponds to a different chemical base. Okay, so for example, when you talk about sweet, the sweet taste, it has to do with the presence of sugars, right? So glucose, fructose. When you talk about sour taste, it has to do with the presence of hydrogen ions. Okay, H plus, which comes from all different kinds of acids like acetic acid, citric acid, right? Then you have salty. So it comes from the presence of sodium ions, Na plus, right? And other um, alkali ions. Okay. Then you have bitter, the bitter taste. That comes from the presence of alkaloids. Okay, alkaloids matlab something like caffeine. Okay. Then you have umami. Umami corresponds to the presence of glutamate. जैसे have you all eaten, what is that green thing that comes in Pan Asian cuisine? Um, what it looks like green peas, wasabi. Yes. Okay, so that wasabi thing, not matcha, wasabi. If you've eaten that, if you've ever eaten sushis or anything in a Pan Asian restaurant, they give it in a very small quantity. The first time I went to a Pan Asian restaurant and I saw it, I didn't know what it was. Okay, so मुझे लगा होगा मिर्ची का कुछ चटनी वटनी. So I was wondering कि why is it in such less quantity. So I just had it as is, and oh my god, you can imagine those who have tasted it, you'll realize what happens to your brain when you eat it, right? So that is basically your umami flavor. Divya is asking, do we have umami flavor in Indian cuisine? Yes, we have. You've ever eaten a raw garlic pod? The kind of the intensity of that thing, something that hits your head, that is umami. Okay, and okay, yeah. So umami flavor is definitely there in the Indian cuisine. It's just that we have not traditionally labeled it as umami. It is a very meaty taste, or it is a very savory taste. Okay. So yeah, in fact, mushrooms also are rich in glutamate. Then fermented foods like pickles. You know, uh, when you keep fermented foods outside, pickles outside for a very long time, वो एक different kind of flavor develops, that is also umami. Okay, because the microbial breakdown enhances the umami flavor. Okay, fine. Anyway, moving on. So that's that. Metallic taste, which area does it stimulate? I just explained that. I spoke about metal ions, right? I spoke about the so metallic taste can be described as bitter, and very a coin on your tongue kind of a taste. No. So it's basically going to activate both your bitter and sour pathways. Okay. Okay. Anyway, moving on. Then we have the olfactory sense. Okay. Olfactory sense is basically when the molecules in the air enter the nose, they dissolve in the mucus, okay, at the top of your nasal cavity. And these molecules then activate your olfactory receptor cells. Okay, olfactory receptor cells. So what is the pathway? The signals travel from these receptor cells to your olfactory bulb. Okay, and then they go to your brain. Now, the olfactory sense, keep this in mind, is the only sense which bypasses the thalamus. It does not go via thalamus. You remember what I said? Thalamus is your relay center. But smell is the only thing that bypasses the thalamus, and it directly goes to your amygdala, your hippocampus, and your orbitofrontal cortex. Okay. And that is why we associate smells with memory. Like I remember uh, when I think of summers, all I can think of is that dermicool powder and its fragrance. You know why is that? Because the fragrance and nostalgia, they are connected to each other. Okay. Now, that is why. Also, one of the fun facts is that dogs and cats have a much larger olfactory surface than humans. That is why their sense of smell is far more powerful than humans. Okay. Then I have to quickly rush through this because now we only have 5 minutes left. The vestibular sense. The vestibular sense basically tells you your head position. It tells you about movement. It tells you which way is up, which way is down. It basically helps you stay balanced and coordinated. And where is it? I've shown you in the diagram. It is in the inner ear, right? Right next to your cochlea. Okay. The main parts are the semicircular canals, and your semicircular canals basically help detect rotational movements. Okay. Like turning your head. Then there is also something known as otolith organs. Otolith organs basically detect linear movement. Linear movement basically means moving forward, tilting your head, gravity. Okay? So what basically happens is that when you move your head, it causes the fluid inside the canals to shift, which bends hair cells. Okay? And these hair cells send the signals through the vestibular nerve. That is why do we feel dizzy when the fluid in the canals keeps moving even after you stop? Let's say you've been spinning for some time and then you stop. Still the fluid in the canal keeps moving even after you stop. So your brain gets confused कि भाई ये क्या हो रहा है? That causes motion sickness or that causes dizziness. Okay. And then you have your kinesthetic sense. So what does it do? It helps you like sense the position and movement of your body parts even when your eyes are closed. Okay, so the receptors in your muscles, in your joints, in your tendons, they basically detect changes in the position. They detect tension. Okay, so these signals go to your brain and then they help you coordinate movements, know where your limbs are located. They help you move smoothly, more accurately, right? So, for example, if I ask you to close your eyes and if I ask you to touch your nose, that is possible because of your kinesthetic sense. Okay. Now, people who work on their laptops very frequently. So now, for example, I am always stuck to my laptop for good 8 to 10 hours a day. So now I can type without looking at the keyboard. Why is that happening? Because of my kinesthetic sense, right? Balancing on one foot while you're shifting your weight, that also happens because of your kinesthetic sense. All right. So with this, we finish an overview of our sensory system. Now what we'll do is we'll quickly look at the MCQs first, and then I will look at the chat box and if you have any questions because we are running out of time. Okay. So let's go. The first question. Which of the following correctly explains why smells often evoke strong emotional memories? What is the answer? Correct. Smell signals bypass the thalamus, project directly to the amygdala and hippocampus. Very good. Next, which of the following correctly matches the receptor type to its function? What do you think it is? Which of the following correctly matches the receptor type? We've just done this. We spoke about, yes, the Pacinian corpuscles. Quickly, I'll go there so that we can see what we had written. When we talk about pressure and vibration, we speak about Pacinian corpuscles and Meissner's, right? So it is C. Okay, moving on. Next, which of the following tastes is correctly matched with its chemical basis? Correct. Sour hydrogen ions. Very good. Next, which of the following is least likely to be affected if there is damage to the parietal lobe? Correct. C, balance and gaze stabilization. Because that has to do with what? Your vestibular system, correct? Vestibular system. And obviously, I mean, your visual cortex is also involved and your cerebellum is also involved. But yeah, fine. Next, last question. Which structure in the eye is responsible for sharp central vision and contains only cones? Correct. Fovea. Perfect. Fine. So with this, we end today's lecture. Uh, Any questions? One question that I had seen is how do I remember difference between vestibular, kinesthetic, and proprioception? Vestibular is basically your balance and head orientation. So you're going to ask yourself, what am I doing in the space? Am I upright? Am I falling? Am I spinning? So the key term to remember in terms of vestibular sense is balance. Okay, so it is going to be linked to your cerebellum, the vestibular nuclei. When you talk about kinesthetic sense, it has to do with your movement awareness. So for example, how fast am I moving my arm or leg? Okay, so the key term in kinesthetic is going to be your motion because it informs your voluntary movements, okay, your speed, when you can feel yourself walking even when you close your eyes, right? It has to do something with movement, okay, and it is going to be linked to your somatosensory cortex, which is in your parietal lobe. And proprioception is basically your sense of position. So where is my body part right now? Something like that. Okay. Are we clear about this? Okay, next. Any other questions do we have? What does it mean for certain tactile areas to become less sensitive or numb over time? Um, so basically, when the tactile sensation reduces or something goes numb, you can say that there is some kind of disruption in your somatosensory pathway. Okay. तो शायद मैकेनोरिसेप्टर्स degenerate हुए रहेंगे या become less responsive because of some like because of age or trauma or overstimulation, or when there is constant pressure, then your body sort of adapts and then the receptors stop firing, right? For example, when you've just worn your watch, you can feel it on your wrist for some time, right? But after a while you stop feeling your watch on your hand. Why? Because now you've gotten used to it. Okay, fine. What are nerve? Okay, free nerve endings. Free nerve endings basically when you think of your neurons, right? Uh, like I said, for you to be able to detect uh, some kind of pain or some kind of pressure, free nerve endings are going to be important. These are your dendritic ends, okay? Your sensory neurons, which are there, which lie right under your skin, they have bare dendritic ends, okay? And they are ready to respond to the changes in the environment. So that is basically your free nerve endings, okay? Oh, so this is an homework which I'll give you. I want you all this, I'll ask you in the next lecture because it's already 8:10. Find out what is the difference between habituation and sensory adaptation. Okay? We'll talk about it in the next class. Fine? So let's wrap it up. Shannon, if you're here, you can take it over.
Hello. You can stop recording, by the way.
Just a minute. Done.
Yes, yes, yeah. Sometimes you can also stop streaming. Hello, people. How are you all?